example 2 is the second big idea for chapter 7. I give these questions a name. Sometimes if you give harder questions or more difficult questions a name that you call them something, it makes the steps easier to remember. So we're going to call these questions multi-revolution questions. And multi-revolution questions will always be solving questions that there is something inside of sign other than just an x. So you notice we have sign 3x, there's like a b value in there. Sign 3x is equal to 0. And this is going to be a multi-revolution question because that 3 is a horizontal compression. Here's a visual of what's happening. Normally, your sine graph between 0 and 2 pi, you would divide it into 4 equal sections. You don't have to write this down. This is just to visualize what's happening. Here's our sine graph. Maximum 1, min, negative 1. Sine graph starts in the middle, going up, so you go middle, then max, then middle, then min, then middle. Here's our regular sine graph. So normally, if you were solving for where is sine equal to 0, you'd be like, oh, here, here, and here. That would be normally for sine of x. Now what we have is we have a compression by 1/3. If I was going to graph sine of 3x, then my graph would get compressed. This is hard to do on the same one, but I would compress this by thirds. So right here would be 2 pi over 3, and it would be divided into 3 4 equal sections. And you would have another 2 pi over 3. And our new graph would go center, max, min. And look like this. That's why I didn't want you to drop down, because it gets very full. But now, can you see that there are a lot of x-intercepts where it's equal to 0? The compression has made us get more answers. How are we going to solve these multi-revolution questions? Here are the steps. So multi-revolution question, steps. Step number 1. Okay, we are going to and I'm putting the 3x in quotation marks because that 3x here is because we have 3x in our equation. If it was a 2x, you'd rewrite the domain for 2x. Okay? So we're going to rewrite the domain for 3x. We'll write all the steps out first, then we will look at what each of these steps mean. 2. Okay? We're going to solve for 3x. Over its domain, and then step 3, we're going to solve for x. So these steps won't really make sense to us until we see the example going with it. These are the steps in general. What does this mean? Okay? The domain right now is 0 is less than or equal to x is less than or equal to 2 pi. And If 0 is less than or equal to x is less than 2 pi, then what is 3x in between? And here's an easy way for you to visualize this. I'm going to get everybody in this room to pick a number between 0 and 10. Okay? So some people might have 1, some people might have 9, some people might have 7, some people might have 6. Now, if I asked every one of you with the number that you picked to multiply it by 3, does it make sense that now everyone's number is somewhere between 0 and 30? You started picking a number between 0 and 10. I got you to multiply it by 3, and now your number is somewhere between 0 and 30. The same thing is going to happen here. If the x number is somewhere between 0 and 2 pi, and we multiplied it by 3, can you see that 3x would be somewhere between 0 and 6 pi? Does that make sense? And if that makes sense, this is why these are going to be called multi-revolution questions, because 0 to 6 pi is once, twice, 3 times around your circle. So you're going to be solving, but thinking about going 3 times around your circle instead of just once around your circle. And that's why I call them multi-revolution questions, because you're going around the circle more than once. If you search up multi-revolution trig questions on Google, probably, like, this is my own name, I made it up. I don't think anybody else in the world calls it this. So don't just go to your friend and, oh, are you doing multi-revolution questions? They'll be like, have no idea what you're talking about. This is JR only works to help you learn. Okay? So that's step 1. We're going to rewrite our domain for 3x. Right? If it was a 2x, you'd double everything. If it was a 5x, you multiply everything by 5. Okay? Step 2, solve for 3x. So we're just solving when is sine 3x equals 0. Well, sine is your y-coordinate, so we write 3x equals, when is your y-coordinate 0? Well, that's easy. It's at 0. It's at pi. It's at 2 pi. That's the first time around. Agreed? But how many times do we need to go around? Because it says solve for 3x over its domain. This one in the multi-revolution, we got to go 3 times around. Second time around would be 2 pi, 3 pi, and 4 pi. The third time around would be 5 pi and 6 pi. But I'm not going to write 6 pi because this question didn't have a line underneath the 6 pi. So we have to be really careful with the domain. Textbook decided to put a less than or equals with a 0, but just a less than sign with a 2 pi. Normally on the third time around, you'd also get 6 pi, but we can't include it because of the domain given in this question. So we have done step 2. We solve for x over its domain. Then finally, step 3 says solve for x. Well, if I wanted to get x by itself, I could take each of these answers and divide it by 3. Because this is what 3x was, right? Just like if I said, well, what's your new number? And you said 24, and I said, I'm going to guess, was your first number 8? You'd be like, wow. It's not that impressive, because you just had to divide by 3. But whatever number you had, when you multiply by 3, if you want to get back to your number originally, you'd have to divide by 3. That's all we're going to do now, is take each of these. This will be 0. This one divided by 3, pi over 3. 2 pi over 3. 3 pi divided by 3, pi. 4 pi over 3. And 5 pi over 3. And this is a multi-revolution question. We'll do a couple more. Part B says state the general solution. Well, in part A, we just solved for x between 0 and 2 pi. Therefore, the general solution for part B our general solution says, our steps that we wrote down, general solution says, first solve between 0 and 2 pi. That was done. Then take all of your answers, so we'll write 0, pi over 3, 2 pi over 3, pi, 4 pi over 3, and 5 pi over 3. Add 2k pi to each of them. Where k is an integer, and we have the general solution. So we'll do another multi-revolution one together. You can, if you're out of room, you can add it to page 577. Step 1, write out the domain for 2 theta this time. So if 0 is less than or equal to theta is less than or equal to 2 pi, then 2 thetas would be between 0 and 4 pi. This is now thinking we are going twice around the circle. Step 2, solve for 2 theta. Well, tan of 2 theta is negative root 3. Root 3 is on your pi plate. Which family is it? Pi over 3 family. Where is tangent negative? Quadrants 2 and quadrants 4. So the first time around my circle, pi over 3 family in quadrant 2, 2 pi over 3. Pi over 3 family in quadrant 4, 5 pi over 3. Now we have to do the second time around the circle. If you went all the way around the circle once, and then ended at 2 pi over 3 again, what would that angle be? So what we're imagining is we are finding what is coterminal with 2 pi over 3. That would be like adding 2 pi. Now, if I'm adding something to a fraction, you're going to have to get really good at getting common denominators. 2 pi is the same as adding 6 pi over 3. And if I add 6 pi over 3 to 2 pi over 3, I'm going to get 8 pi over 3. If I add 6 pi over 3 to 5 pi over 3, I'm going to get 11 pi over 3. And those will be the 2 answers in the second time around. Our new domain goes twice around to 4 pi, so we should get 4 answers. Finally, the last step, we solve for theta, and we solve for theta by dividing everything by 2. Mathematically, dividing by 2 is the same as multiplying by a half. So multiplying by half would just multiply the bottoms or the denominators of each of these by 2. So I would get 2 pi over 6, 5 pi over 6, 8 pi over 6, and 11 pi over 6. You could reduce those if you wanted, but you don't need to. And And these would be the solutions between 0 and 2 pi. So again, a multi-revolution question is really a review of chapter 6 stuff. We still have to be able to solve, know our unit circle, figure out the values. What's new is that the domain, we have to think of the domain getting changed, solving for 2 theta over the new domain, and then coming back and solving for theta afterwards. Questions you can circle. Number 10.